All right, so the lab that we're doing today is basically just kind of an exercise to get us some more practical experience with accelerated motion, because obviously we've been talking about acceleration in the last few days, and to kind of quickly go back and review the two graphs that we talked about in this unit as well, position versus time and velocity versus time. We're not going to do much with the position versus time graph that we created in this lab. We're mostly just concerned with its shape and whether it looks right. Okay, but we are going to be doing a fair amount of stuff with the velocity versus time graph, because that's the one where we can get things like acceleration, displacement, and all of that kind of stuff. And those are things you're going to be asked to do, okay, using your data and stuff from this particular lab. So the problem we're investigating: what type of motion is experienced by a cart rolling down an incline? So remember that for you, you need to somehow rephrase that in your own words in the form of a question. Okay, we're investigating acceleration and what it is in this lab. Okay, so for our design, we are running only one trial here. Okay, we are just allowing the cart to run down the ramp. Okay, I want you to think about the two graphs that we're making: position versus time, and velocity versus time, and what we might be manipulating a little bit in this lab. You know, that thing that affects how fast and how far it goes. Yeah. Okay. So we're going to be, you got to remember, you're identifying your manipulated variable, explaining how and why it's being manipulated. Okay, so it's basically how it affects the experiment and what you're doing. Your responding variables. There's more than one for this lab. That's incidentally why there's more than one graph. Possibly the other things that are on those graphs might be the responding variables, in as much as they respond to how long the cart is allowed to go for. Okay. I need you to think about your controlled variables. Remember, you need to identify and explain each one of them. Okay? How it's being controlled and why it's being controlled. In other words, how it would affect the experiment if it weren't. So in this lab, as I said, one trial only. We're just setting up a ramp and letting the cart go down the ramp. Okay? There's some things that kind of need to stay the same, and some that are just going to stay the same, regardless of what we do, okay, throughout that run. Okay? Anything that can affect the cart's acceleration needs to be controlled, including its acceleration. So its acceleration is one of the controlled variables. You're welcome. Okay? You need to think of two other things that could affect the rate at which the cart accelerates down the ramp. The reason we need that to be controlled is we need the graph to look a certain way. We need a nice uniform acceleration down the ramp. Okay? That's the whole reason we're using a cart and a ramp. It's exactly what you get in that situation. The ramp does not need to be super steep. Okay? On the same hand, it's got to be, a little bit steep. Right? It doesn't need to be like this. That's too steep. Okay? But as you can see in the picture there, I've got 3 of those red textbooks underneath it. Okay? And that was lots to get me exactly what I needed in terms of data, but also not happen so fast that I only got a few data points. Okay? That's the danger. If you make it too steep, yeah, you definitely get an acceleration, but you don't get a lot of data points to work with. And if you make it too shallow, well, then you get lots of data points, but their changes the change between them is so small that you can barely see that it's going on. So you kind of got to find that happy medium. Okay. 3 textbooks, and you can see what they look like over on my bookshelf. Okay, for reference, needed about that high. A couple of binders would be lots, okay, to get your height to what you need. Okay. All right, for our hypothesis, the if part. Needs to essentially be a definition of acceleration. If acceleration is, you give me your version of the definition of acceleration. Okay. The and part simply describes the experiment. A cart is being allowed to accelerate down a ramp. Position, velocity, and time are being recorded. Okay? That's all this experiment is. That's why I said, like, the actual acquisition of data for this experiment takes no time at all. Then part is going to need to essentially predict your results. That being, how will you calculate the acceleration of the cart from your velocity versus time graph, not from your data, from your graph of the data. Okay? And I don't mean like in the then part then that you should say, then the acceleration can be calculated by doing this, right? You can simply say, then acceleration is represented by this or something along those lines, okay? But basically, you need to be able to tell me how you'll know acceleration is happening from your graphs, how you're going to calculate it. I'm going to kind of stop explaining there, let you get your data, and we'll look at the graphs, we'll look at the analysis once we're done that, just so we don't overload you here. Okay, so what you need, a cart, a ramp, okay, and somebody with the SparkView software on their phone so that you can track the trial. When you run this, one of your group members needs to catch the cart at the bottom of the ramp. Do not let it go off the bottom of the ramp. Okay, it will jar the little tiny, very sensitive sensor. Okay, so we don't want that. Okay, so please make sure that somebody catches it at the bottom of the ramp. Remember that there's a bit of a delay in it starting. Okay, we kind of saw that in the last lab. So the person who's using the SparkView app, press the red button and wait till you start seeing something happen, then let go of the cart and let it go down the ramp. Okay? You can stop it when it hits the person's hand and the delay will catch it and okay, you'll be fine from there. We can always edit out the points the same as we did the last time that don't fit. Okay? All right, so get yourself into groups, okay, and grab the equipment that you need. Someone can have this ramp if they want it. So once you've exported the data, okay, sent it to everybody, and they've opened it up, hopefully through Google Drive. Do I need to go through that step? Everybody's okay with that? Okay, so you've got this, right? It's recorded everything. We don't need everything. We need the time, the position, and the velocity. That's it. Delete everything else. Okay, so don't need date and time. Okay, I don't need force for run one. I don't need any of the accelerations, oddly enough, as it's the acceleration lab. Okay, so I'm going to get rid of all of those. Delete selected columns. Okay, now I've got time for run two, position for run two, velocity for run two. Okay, I don't need any of these other ones, so I'm going to get rid of them as well. Okay, so now I've got the two things that I need. Now, I actually have to make another sheet. I can't graph these on the same sheet because they're different things. I can't put them on the same graph. So what you're going to need to do is first off create a new sheet. So it says add sheet down here at the bottom. Okay, click on that, and open up a new sheet. Okay, then go back to the original sheet and copy the time column. Okay, and go back to the second sheet and just paste it in there. And then cut the velocity data. Don't copy it, cut it. You want to take it off of this sheet and move it to the other one. We just want the times to be the same. So we're going to cut it and paste it. Okay. So now we've got two different sheets because we're going to be doing two different graphs. This one is the one I'll build my position versus time graph from, and the other one is the one I'll build my velocity versus time graph from. Okay, so very much like the first lab, okay, I'm just going to highlight everything, insert chart, okay, and it actually gave me a scatter plot, which is what I wanted. Okay, but I've obviously got a lot of data that needs to be taken off. Now, here's the thing. You have to make a note of which points you take off. And you have to take them off of the other graph as well. Okay? So that basically when you're done, your velocity versus time graph and your position versus time graph run for exactly the same amount of time. Because we're going to be comparing the displacement from one of them with the displacement from the other. And it would hardly be fair if my position versus time graph ran for 1.5 seconds and my velocity time graph ran for 0.3 seconds. Okay? They're obviously not going to have the same displacement because they're talking about different amounts of time. Okay? Everyone follow me there? Okay, so when I'm looking at my position versus time graph, I have to make a note of how many points I take off and take off those same points. Okay, so like I'm going to write it down on a piece of paper, okay, so I know which ones I take. Right, so now that I've got that graph, okay, and it's actually, I'll change the title later. Actually, I won't, but you will. Okay. So now I'm just going to move that graph. I didn't set that up very well. I can't. Okay, so I'm looking at the graph, and I'm seeing that my good acceleration probably starts around 1 second. Okay, that's where the graph gets nice and curved. Okay, so I'm just going to go to my data to where 1 second is, right? And it's at like row 22. So what I'm going to do is I'm going to delete everything from row 21 up in the position column. Okay, so I'm highlighting everything from row 21 to row 2. And I'm going to delete those cells and shift up. Okay, so you can see I've got it highlighted here, shift up. Now, row 21. I gotta go to my velocity versus time graph and delete the same ones. So that again, I'm making a fair comparison here. Okay? And even though these numbers look weird, that's okay. They're still going to result in me getting a fair comparison. Okay? So now I'm going to go back to my position versus time graph, and I'm going to delete the ones that came after. Okay? And they seem to start at probably about 1.75 or 1.8 seconds. So I'm just going to go up into my data here. Yep, and I can see that right here, at about 1.85 seconds is where my data starts to retreat. Okay, so I'm going to take everything from row 40. Okay, you can see here I'm at row 40. I'm going to take everything from row 40 down, and I'm actually going to delete it all. Okay, time and position, all the way to the bottom. I'm going to delete those cells and shift up. All right, now I got a graph that looks pretty good. I got a few points here that are meh, but I'm going to leave them. Okay, I'm going to go back to the other sheet. Okay, and it was row 40. Okay, and from there, I'm going to, yeah, definitely, actually row 39 on this, but I'm going to keep it this way. Okay, I'm going to take all, oops, I clicked. So row 40, yeah, all the way to the bottom. Okay, so now I'm talking about the same amount of time for both of my graphs, 1.85 seconds for both of them. Okay, so it's a fair comparison now. So I build my velocity versus time graph, okay, then I put them both in my report. Everybody with me there? Okay, so that when you manipulate your data, make a note of which points you delete from your position time graph, delete the same ones from the velocity versus time graph so that we get a fair comparison. Oh, that's the same graph. Okay, so yeah, I got these weird points here at the end, okay, not ideal, but you know, I can always go back, I can look at this now and go, okay, so this one here is actually at 1.6 seconds, and I don't want these points here, okay? So now that I've looked at my velocity versus time graph, I can go back and delete those off of both, okay? So I'm gonna go into my data, and move this over. At 1.6 seconds, that's the one I don't want anymore. Okay, so I'm going to go down to 1.6 seconds. I'm actually going to delete everything from there on from both charts. Okay, now I've got a nice looking graph there. Do the same thing here. 1.6 seconds, delete everything from there down. Okay, and that's going to alter that graph. Look at that. Like, it doesn't get any better for those graphs. Okay, that's exactly what they should look like. I should have a curved position versus time graph, and I should have a nice linear velocity versus time graph, and that's exactly what I've got. Okay, and your data will be exactly the same thing. It can't help but do that. Okay. All right, when you get to the analysis, okay, question number 1 says, using your graphs, identify the type of motion that occurred in this lab and show calculations to prove and explain your reasoning. So here's what I'm looking for question number 1. Look at the shapes of both graphs and explain to me why those shapes mean the object is accelerating. So look at the shape of your position versus time graph. Tell me, hey, it looks like this, and that means this, okay, and that's why it's accelerating. Okay, same thing for your velocity versus time graph. My velocity versus time graph looks like this. It means the following was going on, and that is exactly what acceleration should look like. Okay, then the calculation that I want comes from your velocity versus time graph. Okay, remember to put a linear fit, okay, on your velocity versus time graph. You need a best fit line on the velocity versus time graph. So we go back to that. This one, okay. I'm going to open up the chart editor again here and go to customize, and this is where I want my trend line. So I'm in series right now, guys. I click on trend line, and I click on use equation here where it says label. And I'm recording all this if you get lost. Okay? All right. So now, there we go. I've got y equals 0.859 times x plus negative 0.0839. Okay, so I've got the equation for the line. So the calculation that I want for question number 1 to prove acceleration is occurring is for you to take this equation and manipulate it without plugging in any numbers to show it solving for acceleration. Remember to put units on that. One of these numbers will need the units for acceleration. Okay? All right, so that's question number 1. Question number 2 wants you to calculate the displacement and compare it between the two graphs. All right, so you got to think about, all right, how do I calculate displacement from this graph, and how do I calculate displacement from my other graph? Okay, calculate the displacement from both, and then compare the two numbers. What should you notice? They better be dang close. Okay, like really, really close. We are talking about how we preserved our data. It was exactly the same time, exactly the same points. When I do this, I should be closer than 5 centimeters. Okay, like the difference between my position versus time graph when I calculate and my velocity versus time graph should be less than 5 centimeters. Certainly less than 10. If you're way out, okay, then you did something wrong. Okay, everyone follow me. I'm going to want to see those calculations as part of the answer for number 2. Okay, show me how you calculated your displacement from this graph and how you calculated your displacement from the other graph, okay, and then talk about the comparison. Okay. Then conclusion, same as always, copy paste your hypothesis. Does your data support or reject? Give me an explanation, and then sources of error. 2, and ways to fix them. Okay, same as always. Okay. Are there any questions there? Okay, if more come up, just ask. You've got the rest of class to work on that lab report, so you should be able to get a lot of it done, because you still have almost 45 minutes to work on it.